So in previous class we have discussed about the artificial neural networks as well as biological neural networks. In this class we can see what is like that artificial neuron, how they are comparing with artificial neurons with the physical neuron. See, from this diagram we have got the input is dendrites, then we have got soma, that is cell body, that is called processing unit, then synapse, then we have got axon. Similarly we have to compare with this biological neural networks into artificial neurons. So here the dendrites will act as a input signal, then soma will act as a processing unit, then we have got axon that is used to connect the one's neurons into another neurons. So here the axon, that is synapse, will act as a weight for this example. So in case of artificial neural network, from the example we have got the inputs. For example, here the diagram indicates there are three inputs, input 1, input 2 up to input n. Next we have got first we have got a variable weights, so we have to assign the weights, then we have to perform the summation function. So what is the formula which we are using means, for example, the calculated output y is equal to that is bias plus weight function into input units. For example, y is equal to bias b plus wi into xi. Here b indicates bias, w indicates weight, x indicates input, w indicates weight. Then we have to perform the activation function and we have to produce the output. Here what is the function of weight? What is the meaning of bias? So these are all called learning parameters. So what is meant by weight means, weight defines, for example, if you are processing the input information, it defines the how much importance of the input information that can be understood by the function called weights, that is indicated by W. For example, if we are studying 50 pages, the page number 5 is very important, page number 10 is very important, page number 20 is very important. So we have to provide more attention. Similarly, in a network, if you are training any data, input for some input information, for important input information, we have to provide large attention. So for that we are giving the large number of weights. For less important information, we have to provide less attention. So for that we are providing the less weights. So weight dictates how much the information, how much importance, the importance of the input information that can be decided by the weights. Then bias. So bias is an additional value which we are adding to provide the flexibility in the application of activation function. So the bias used to activate the activation function. Suppose if we are not using bias in any network, for example, the formula already I have discussed, y is equal to bias plus summation of xi into wi. Suppose if w weight is 0, then if you are not giving bias means then entire network will come as a 0. To avoid this kind of problem, we are adding the bias. So bias provides linearity as well as flexibility as well as used to activate the activation function. So these are all the two parameters which we are using in the updation of learning parameters in the artificial neurons. So this is the general development studies about ANN. So information processing occurs at many simple elements called neuron. So the processing occurs the elements called neurons like soma. Then signals are passed between neurons over connection links. That is, each connection has a weight which is a typical neural network multiplies the signal transmitted. So we have to perform the formula y is equal to bias plus wi into xi. That means we have to do the summation with bias as well as the multiplication of weight with input. Each neurons applies an activation function to its net input to find out the output signal. So here the term called activation function means it is used to provide the linearity in the processing data. So there are different types of activation function which we are having in the neural networks model. Like we have got leaky activation function, leaky ReLU activation function, leaky ReLU activation function, then we have got sigmoid activation function, then we have got tanh or bipolar sigmoid activation function, then we have got softmax activation function. So these are all the different types of activation function which we are using in the deep learning model, that in the neural networks, to introduce the non-linearity. For example, if the network is linear, then it is not possible to understand the complex type of problems. Then what we have to make means we have to introduce the non-linearity. So this non-linearity can be introduced by having the activation function. So here ReLU means rectified linear units. Here the ReLU activation function mainly used in hidden layer applications. So that means if you are giving the input data, the output provides, for example, input if it is greater than 0, whatever the value it is giving, that provides as x. Other than that, if the input is lesser than 0, then the output is 0. So whatever the input we are giving, the output will become either 0 or x. X here the input same value. So if greater than 0, whatever the input we are giving, so the same will get output. If lesser than 0, so we have to get only 0. So it provides linear function. So it is called a rectified linear unit. So that is called ReLU function. So this ReLU function mainly used in hidden layer applications. So small modification ReLU function called leaky ReLU. So here leaky ReLU means, so normally the ReLU act 0 to x, but leaky ReLU means it can support small number of negative values. That is called a leaky ReLU function. So this ReLU and leaky ReLU functions both are applied in hidden layer functions. Next one is sigmoid activation function and softmax function. Sigmoid activation function, the input whatever we are giving, it provides the positive polar, that is 0 to 1. The formula is 1 by 1 plus e power minus x. So x indicates input value. So if you are giving some different input values, the output varies from only 0 to 1. Similarly, bipolar sigmoid activation function, here the formula is 2 by 1 plus e power minus x minus 1. That means the output varies from minus 1 to plus 1. That is sigmoid activation function works from 0 to plus 1. Bipolar sigmoid activation function, it works minus 1 to plus 1. Next, finally, this sigmoid activation function mainly useful for binary classification problem. That this softmax, that is the another activation function which we are using in the network, that is mainly useful for multi-class classification function. So what is binary class means? Yes or no, it provides yes or no. There are different analyzing, that is called, one is called classification and one more is called regression. So classification means we can say either yes or no, but regression means it useful for 0.7, 0.6, 0.5. That is percentage, how many percentage value, that problems we can use for regression. Multi-class means, for example, if I am having the tumor, binary classification means it will give the output only two values, that is yes or no. That is tumor is present or tumor is absent, that is called yes or no. But in multi-class classification, for example, if you are having 4 grades of tumor, to find out the level of the tumor, grade 1, grade 2, grade 3, grade 4, that is mild, severe, very severe, moderate. So this kind of different, that is meningioma, malignant, this is different severity level. So for severity level classification, we can go for multi-class classification function. So for that multi-class classification function, mainly we can use softmax activation functions, because softmax means whatever the input we are giving, it provides the output with the probability range. That means if your values are 0 to 1, the probability, there are 3 classifications. One, it may be a 0.35, another may be a 0.2, and another may be a 0.45. If you are adding these 3, finally you will get 1. So whatever the values, whatever the probability we are giving, if you are getting summation function, the output becomes 1. That is called a softmax activation function. So these are all the different activation function which we are using in the neural networks model to to introduce the non-linearity in the network, to analyze the complex problems in the network. So this is about the introductions and artificial networks and artificial neural network, structure of the network, everything. So in next class we will discuss the applications and we will enter the different types of learning models in the ANN.